0, because they're x-intercepts, right? Gotta have zeros here. Okay, let's find the vertex. Does anybody remember? It's a different formula. What is it?
It is x equals t plus t divided by t.
Excellent. So this is the same, has the same function as the negative b over 2a. But remember that negative b over 2a, that's for standard form, and this is an intercept. So this is like the same deal, but it's for intercept form. You have to have this one memorized too. The only stuff I'm giving you is that. Okay? So p was negative 3 and q was 1. What's negative 3 plus 1?
Negative 2.
Thank you. Negative 2. And what's negative 2 divided by 2?
Negative 1.
Negative 1. So that means the x value for my vertex is negative 1. This should be a real easy question. How do I find the y value?
Plug it in.
Yeah. Plug it into that original function, right? Plug in negative 1 for x and see what you get. So I would have this. And if you put it in the calculator exactly like that, it will give you the right answer, okay? Which would be 4. Yeah, you're right, because this would be 2 and negative 2, and yes, it would work out to be a positive 4. Okay, before I pick these points, I'm going to graph these 3. For some people, it's easier to see what numbers to choose here if you've got the other 3 already graphed, right? So negative 1, 4. Negative 3, 0. 1, 0. You'll notice, in between my vertex and this intercept, there's a x value right here that doesn't have a point on it. I would like for there to be a point right here along this x value. What is the x value along this line that I'm moving the pin up now? Yeah, this is where x equals 0, right? So that's one of the x values I'm choosing. You'll notice, there's another one. Here's this line. It's going in between these 2 points. I want a point to be there. What? Good. And now I'm going to plug these in. So I got negative 2 plus 3, negative 2 minus 1, and I want to know what that is. So I'll give you a second. What is it? 3. Excellent. You should make sure you get the same, right? Okay, so I just got to graph those last 2 and I'm done. Negative 2, 3, and 0, 3. 0, 3. We got it? Any questions? So I think, when you're seeing it done, it's easy to follow. It's just a matter of going over it tonight just to make sure you can recognize each form and you kind of know. The procedures are a lot the same and there's little differences, and just make sure you know the little differences for each one. I tell you what I'm going to do for the time being. I'm going to skip 8. I just want to make sure we don't run out of time. 8's just like 7, right? We'll probably have time to come back to it. Okay, number 9. I'll try and get you a tripod before I ask you to do this again, so you don't have to hold back the whole time. All right. I know that's going to be uncomfortable. Thank you. All right, number 9. Does anybody remember the procedure? Raise your hand if you know the procedure for determining whether something is even, odd, or neither. You remember it, Bailey?
You gotta change the x's to negative there.
It's exactly it. And then I'm going to compare that to my original function, right? So I know g of x. I'm going to find g of negative x, and that just means plugging negative x's in everywhere there were x's. So I get to this x. It's no longer an x. It is now a negative x squared. Notice I put it in parentheses. Minus 4. Now I want to simplify this if I can. Raise your hand if you know what negative x squared simplifies to be. Got it. Just positive x? X squared. Good. So here's why, just to remind you. Negative x squared means negative x times negative x. What's negative x, what's a negative times a negative? A positive, so I know I'm going to get a positive here. And x times x, I would be adding the exponents, and 1 plus 1 is 2. So I would get positive x squared. Okay, that's just a reminder of why that works out. So that means this really simplifies to be 3x squared minus 4. Compare this to this. What's true about those two things? They are exactly the same. Does anybody remember what that means? Even. Good, y'all. Very good. I'm impressed. Even. Okay? Number 10. Same deal. I'm doing this. The procedure is exactly the same. I'm going to find g of negative x and compare it to g of x, and that'll help me determine if it's even, odd, or neither. So I'm going to plug in negative x. What's negative 1/3 times negative x? Be bold.
1/3 x.
That's it. A negative times a negative is a positive. So this just equals 1/3 x. Compare this to this.
Odd.
How do they compare? They are opposite signs, right? So before I realized I'd just been saying the word opposite, just to make it more clear, I mean opposite signs. That means every sign is opposite in the problem. So this term is negative, it's only one term. Here it's negative, here it's positive. Otherwise it's the same except for the sign. That makes it odd. Right? They are exactly opposite, it's odd. And then number 11, which I think I can fit on here. Same deal. So here's the original. And if I find g of negative x, I'm going to substitute a negative x everywhere I had an x. Minus 5 times negative x minus 3. Okay, let's simplify. We figured out last time that negative x squared was just x squared. So this is 4x squared. And negative 5 times negative x would turn into, good, plus 5x. And then the minus 3 is still minus 3. It didn't change.
Wait, so 4 ain't negative? Because it's positive right there, and on the inside it's negative.
Okay, so remember order of ops. I have to do the negative x squared first, but remember negative x squared just turns into an x squared, right? So this negative never has a chance to touch the 4. Okay, now let's compare these two. Are they the same?
Somewhat.
No, they're not.
They have to be exactly the same. Are they exactly the same?
No.
Are they exactly opposite?
No.
Yeah, good. To be exactly opposite, all the signs would have to be opposite, right? So it's like a mixture. It's kind of opposite because these are, and it's kind of the same because these two are the same. When it's a mixture like that, what does that mean? Neither. Good. Now, I think I'm about to answer the question you're about to ask. On the test, let me warn you that I will probably not have one even, one odd, and one neither. Is that what you're going to ask me? Because that makes it a little too easy. They might all be even. They might all be odd. Who knows? So don't count on it being one even and one odd and one neither, because that may or may not happen. Okay? Any other questions about these? Cameron, I'll tell you what, I'll give you a break for a second. Set it down. Don't stop it, but you can set it down. If you're getting worn out, we'll take a break. Are you good? You can give me a thumbs up if you want me to keep going. Okay. Okay. True documentarian right here. He will not speak to me, apparently, while he's filming. He doesn't want to interfere. All right, so number 12. Number 12 and 13 ask me to do 3 things. Tell whether it represents a linear, an exponential, or quadratic function. That's one thing. Explain your reasoning. So tell me how you know that. That's the second thing. Then write the function. That's the third thing. I am going to promise to have actual tables on the test tomorrow. They won't be written on. I guess y'all figured out. Did y'all figure out that
He told
these?
us.
Yeah.
Okay, he told you. Okay, good. Okay, so I don't want you to graph them. That's not how I want you to do this. I want you to do it the way we did it on the homework that we went over a few minutes ago. Check for first differences first, then second differences, then a common ratio, unless you can look at it and tell what kind it is, right? In which case you can kind of skip ahead. So, first differences. What am I adding to get from 15 to 8?
Negative 7.
-7. From 8 to 1?
Negative
Oh,
7.
from 1 to -6? And from -6 to -13? Well, that's good, because that means the first differences are constant. What does that mean this is? Linear. Remember, if the first differences are constant, it is linear, and my explanation is going to be just that. My explanation is the first differences are constant. That's it. That's all I need in the way of explanation. It doesn't have to be a paragraph, nothing crazy. Just tell me how you knew. And then the last thing is probably the hardest part, and that is writing the function. So this is linear. So that means my function is going to look like what?
Y equals mx plus b.
Good. Y equals mx plus b, and I just need to figure out what b and m are. So b is my y-intercept, so it's what? It's in the table. 8, right? Remember, if x is 0, you got a y-intercept on your hands.
Y equals
And m is what?
-7.
Good. It's the thing that I'm adding every time. It's that constant difference. So y equals negative 7x plus 8. And don't forget, you can do little quick checks to make sure it works, like plugging in 0. That would give me 8, so that's good. Or plugging in 1 would give me 1, so that's good, right? Questions about that one? Cool, cool, cool. Let's do number 13. Does anybody need more time with this? Still see some pencils maybe. You got it, Trevor, or you need more? Okay, just tell me when you got it. You got it? Okay, good. All right, 13. Does anybody think they know this one? Just curious. You think you know? What do you think it is?
It's 1 4.
And you think, what kind of function do you think it is?
It will be exponential because it's
Good. You were right on all accounts. So let's get everybody else on the same page with you. Tasha, did you have the same thing? Exponential. Good. Do you happen to have the function? Did you write a function for it? No? We'll get to it. Okay, so again, if you don't immediately look at it and know what kind of function it is, start by checking the first differences. What am I doing to get from 512 to 128?
Add a -284.
Negative 384. From 128 to 32, I'm checking first differences. I know they're wrong. You know they're wrong, but we're checking them. We're assuming we don't know that already. So what would I have to add to get from 128 to 32? You guys have calculators in front of you. You take this number minus this number, and it will just tell you the answer.
-96.
Good. From 32 to 8? So I'm going to try not to go on too epic of a rant, since this is going to be broadcast to the world. But those of you who are not participating in class are also the people who seem to be struggling the most. I think there's what we call a correlation there. Those two things are related.
How come?
Some people are putting things in their calculator every time I ask them to, and some people never do it unless I call them out by name. You know who you are. Participate. It's easier if you involve yourself. Okay? What am I adding to get from 8 to 2? I'm sorry, I'll take it after this. -6. Okay, what's the question, baby?
Like, whenever you like put it in the calculator and you subtract them, it's a positive number, so why are you putting negatives on them?
Because what I'm actually doing is I'm taking this number minus this number. If you do 8 minus 2, you'll get 6. But you should be doing 2 minus 8.
Oh.
8 minus
So
32.
can you just go backwards?
Basically, yeah, you could do that. Okay, so the first differences are not constant. I know it's not linear. Let's check second differences. What am I adding here? From negative 384 to negative 96. Thank you. Got my same usual suspects who are participating and my same usual suspects who are not. This is your warning before your short form. What do I have to add to get from negative 96 to negative 24? 72. What do I have to add to get from negative 24 to negative 6?
18.
Adding 18. So the second differences aren't constant either. So that means it's not what? It's not quadratic. So I'm assuming it has to be exponential. Let's confirm it by checking for a common ratio here. See if we can find that. Well, we already know what it is because Tiffany told us. But most of you, I'm guessing, will think of dividing by 4 first, which is great, as long as you don't write 4 here, because that's not the common ratio. The common ratio has got to be what we're multiplying by. So just remember that dividing by 4 is the same as multiplying by what? 1/4, right? 1 over 4. So 512 times 1 over 4 is 128. 1/4 of 128 is 32. 1/4 of 32 is 8. 1/4 of 8 is 2. So we do have a common ratio. So this is exponential. And the reason is it has a common ratio of 1/4. See if I can get this thing to stop spazzing out. It's pretty sensitive. Okay, the last part is the writing the function. This is the most difficult because you have to know the formula for an exponential function. And you'll notice that is not among the 3 things that I'm giving you tomorrow. So if you don't know it, make sure you learn it tonight. Does anybody know it?
Wait, no, what?
Good. Excellent. Excellent, Caleb. Impressed. Y equals a times b to the x power. Now, this is worth making a note of because this is kind of weird. B before was our y-intercept. It's not now. In this formula, a is your y-intercept, and b is your common ratio. Good, yeah, that's the thing that I'm multiplying by every time, right? So I just got to plug those 2 numbers in. So do I know my y-intercept? Is it in my table? Definitely. What is it? 128. Remember, if x is 0, whatever the y value is, that's your y-intercept. And what's b? What's the common ratio? 1 over 4. Questions on these? How are we doing on time? Oh, mercy. I'm going to work 14 and 15. I'm probably going to skip 16 because it's exactly like 14. Work the exact same way. And then get to the word problems. Because we're running out of time. Anybody need more time on this slide? Okay. 14. So this is like the bell work, right? So this one gives me 3 points. It says it goes through this, and it goes through this, and it goes through this. And it wants me to write a quadratic function in standard form. What form am I going to plug into? Vertex or intercept?
Intercept.
Good, because that's what they gave me. They gave me 2 intercepts, -8, 0, and -2, 0. And I know they're intercepts, x-intercepts, because they have 0 for their y values. So I'm going to plug into this. And these 2 numbers are p and q. So, writing the formula here will help you not make a mistake with the signs. Think of it this way. I go x minus p. That means x minus -8, which I would write how? X minus -8.
X plus 8.
I would write it as x plus 8. X minus q means x minus -2, and I would write that as x plus 2. Okay, I've got the whole function except for a. Have they given me enough information to find it?
Yes.
Yes, because it takes how many points?
3.
And I got 3. So what I'm going to do is use this other point. It is an x and a y. And I'm going to plug in -6 everywhere I see an x. And I'm going to plug in 4